Hi, I'm Logan Cutlip. This is my Pecha assignment, and I chose to do a little geometry, a little sacred geometry, just because I find it interesting. Uh, let's see. First off, what we have is the 5 platonic solids. We have the dodecahedron, the tetrahedron, the octahedron, the isosahedron, and the hexahedron. Now, in order for solid to be a platonic solid, it has to follow 4 rules. The first of which is that all the faces need to be the same, and you can see that here. That all these faces are triangles. So this would follow the first rule. The second rule would be that all the edges need to be the same. You can see that here with 5 feet by 5 feet. The cube is an easy one to use because we all know that, the square has the same length and the same angles, which leads to the next rule. There can only be one angle through the entire shape. And we can see that here with the 90 degrees, again in a square, it's more easily depicted. We know a square has all 90-degree angles. Let's see, and the fourth rule would be that all the edges, if placed inside of a circle, as you can see here, will fit inside the circle perfectly. There's no edges going out, there's none, too short. It fits in that circle perfectly. So those are the 4 rules. We have, let's see, what's up first? We have the dodecahedron. It has 12 pentagonal faces, and 3 of which meet at each vertex. Next up is the tetrahedron, which is 4 triangular faces. 3 meet at each vertex with 6 edges and 4 vertices. There's actually a few triangular platonic solids here. We have up next the octahedron, which is 8 equilateral triangles, 4 of which meet at each vertex. This is a little bit different because they're equilateral rather than not. Up next, we have more triangles. The isosahedron, which is 20 equilateral triangles with 30 edges and 12 vertices, and as you can see, this is just kind of an elongation of the octahedron. It's basically just, added some more triangles to it. Up next, we have the hexahedron, which actually refers to any polyhedron, but the cube in particular, because that is the actual platonic solid that follows all of the rules. Now here's where things start to get a little bit interesting. We have what's known as Metatron's cube. It starts off with these 13 circles. You take a line from each circle to another circle, creating 78 lines, and when you look at it, at first it's just lines, but you notice all the platonic solids are actually represented in this cube. Now, who is Metatron? He's referenced in the Talmud, the Kabbalah, the Book of Enoch, and he's accepted through Christianity and Islam as well. He's referred to as a guiding angel and a scribe. Now let's see where this all starts off with the flower of life. You take a circle, copy it, move it up, down, left, right, half the distance of the diameter, and this little star pattern is created, and it's known as the flower of life, which is the symbol of sacred geometry. You continue the pattern out a little bit further, and you get what's known as the egg of life, and this should look fairly familiar because this is an embryo after just a few hours of cell division, which I think is a pretty cool coincidence. Next up, we have the fruit of life as the pattern continues out. And this should look even more familiar because this is in fact the 13 nodes that's needed to create Metatron's cube. So just a basic circle movement can create all the platonic solids. That's pretty interesting to me. Inside this arrangement of circles, you can find what's known as the tree of life, which is seen in most notably the Kabbalah, which shows how the infinite creates the physical and higher metaphysical realms. And because this pattern can be repeated over and over and over forever, it is actually a fractal. And a fractal is any repeating pattern that can continue for infinity, as this would. Now this is pretty interesting. Some cool stuff in here. There's actually lots and tons of books that you can read up on to find if you're more interested in this. We have the Geometry Code, we have Patterns of Eternity, and a couple examples we have here up on the screen. So if you're interested in that, go ahead and look into that and read up on some sacred geometry. That's all I have for this Pechacha. Thank you for watching, and have a great day.